Hi, third grade friends. We are here today ready to work on lesson 9 of our math unit 5, continuing to work on fractions. We have been working super hard and you have been doing a fantastic job, and we are going to continue that today. So if we look at our lesson objective for today, our lesson says that we are going to build and write fractions greater than one whole using unit fractions. And we don't need that step in the middle, but if we look down, it says, I can build and write fractions bigger than one whole. That is the biggest part of our lesson for today that's different, is that we're writing fractions that are bigger than one whole. So far we've just been dealing with fractions that are within one whole, but today we are expanding, we're going beyond one whole. So I'm going to do a little demo today. So you will need your lesson 9 problem set like this. If you have sticky notes and you want to do this right along with me, it would be a good idea. With math, one of the things with math is that you learn so much more if you have like something concrete to touch and to kind of hold and to manipulate. If you don't have fraction pieces, this is so super simple for us to make. I've got some sticky notes right here. And if I look at my first example, for our directions first says each figure represents one whole, fill a chart. So if we look here, there's a whole, and this one's not a whole. This would be a half, right? Because 1 out of 2 is shaded in. But what I'm going to do, since these pictures represent a whole, I'm going to go ahead and take 3 sticky notes. 1, 2, 3. So if you have sticky notes, or you can just cut out like small pieces of paper or something, I'm actually going to cut the ends of this sticky note off just because I don't want the sticky part of it. Okay, so now I have my 3 pieces of paper here, and these are representing the 3 holes. Okay, so but if I look, each hole in my picture is cut into 1/2. So that's where we get the unit fraction of 1/2, because remember, unit fraction, when we say unit fraction, it means like one piece. Okay, so when we deal with a unit fraction, we're saying what would we call one piece of the picture, of the fraction, of the model. Okay, so one of the pieces, since each whole is broken up into 2, we would call one of the pieces 1/2. So I could actually even write 1/2 inside each one of those. 1/2 plus 1/2 there is a whole. Again, 1/2 and 1/2. So we have 2 holes, and here we have 1/2 that is shaded. Okay, these are representing my 3 holes. But what I'm going to do to my 3 holes is, because here they are both cut in half, I'm going to take it and I'm going to cut it right. Let me just make sure that they're stacked up so that they'll look pretty equal. I'm going to take my 3 holes and then I'm going to cut them in half. Try to make a pretty equal cut. So now I have, this would represent that first triangle, sticking right together. And this would represent the second triangle. What about for this third one? And it's actually, I'm calling them triangles, but they're actually diamonds, right? They're triangles that are put together to make diamonds, or a rhombus. For this third rhombus or diamond, do I put down both of my pieces? I put them both down. Only one of them is shaded, so I'm only going to put down 1. Okay, and all of these pieces here equal 1/2, right? Because it was a whole, and then I broke them up into halves. Okay, so when if I look here for this sample, it says how many are shaded? 1, 2, 3, 4, 5. And then so here we're looking at the fraction shaded. Well, here's all my pieces. Okay, all my pieces that are 1/2. So if I count them up, I've got 1/2, 2 halves. And that's a whole, but I'm going to keep counting. So 1/2, 2 halves, 3 halves, 4 halves, 5 halves. Okay, so 1/2 and 1/2 is a whole. 1/2 and 1/2 is a whole. And then I have this whole left over. So count with me again by halves. 1/2, 2 halves, 3 halves, 4 halves, 5 halves. Okay, so this picture is represented, would be equal to 5 wholes, which is a fraction greater than one whole. And I would also know if I would write them, if I want to write it as a whole. So one whole would be equal to 2 halves, right? I do this, okay? 2 halves is equal to a whole because there would be, like my numerator and denominator is matching, that's equal to a whole. But 5 halves is greater than one whole or 2 halves because my numerator is bigger, right? Plus we have these 2 wholes plus some left over. So let's count by halves one more time. 1/2, 2 halves, 3 halves, 4 halves, 5 halves. Okay. So a unit fraction would be 1/2 because each one of these pieces is a half. There's 5 shaded, and when I count 5 1/2 pieces, I get 5 halves. And again, that's bigger than a whole. Would actually be equal to 2 wholes and then a half. Do we see that? Okay. Let's take a look at some more of these and see. So this is different today, so it might be a little bit confusing. That means we just need to kind of power it up and just try a little bit harder, right? Just try to really think and really concentrate. If something is a little bit different, sometimes we just have to kind of work harder to wrap our math brains around it, okay? All right, so if we look at B, the first part of our chart says the unit fraction. So I know it's going to be 1 over something because I want to name each piece. So for my denominator, it's the total number of pieces. So if I look, I've got 1, 2, 3, 4, 5, 6, 7, 8. So my denominator is 8 because each one of those pieces would be 1 out of 8 total pieces needed to make a whole. Okay, there's 1 out of 8 total pieces needed to make a whole. So the next part is how many parts are shaded. Okay, and if I look, I've got, well, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. There is 15 pieces that are shaded. Okay. And if I look, each piece is 1/8. So I'm going to show you a couple different ways. Let's count by 1/8 until we have counted all of our shaded pieces. Okay. So I'm going to put like a heavier dot here. I want to start right here. And that's going to be my starting point, and then I'm going to kind of go around in a circle. Okay, but we're going to count by one. We're going to count by eighths. Here we go. 1/8, 2/8, 3/8, 4/8, 5/8, 6/8, 7/8, 8/8, which makes sense because it's a whole. Okay, we're not done though, right? Because we have all this over here. So 8/8, 9/8, 10/8, 11/8, 12/8, 13/8, 14/8, 15/8. Which makes sense, right? Because there's 15 shaded and my denominator is 8. So there's 15 shaded and there's a denominator of 8 because there's 8 in each whole. So my total here would be 15 eighths. Now the mistake that kids make a lot of times is they would put, okay, there's 15 shaded, and then they would combine 8 plus 8 is 16. So the biggest thing that kids want to do is they want to say 15 over 16, okay? But that doesn't work because it would be 15/16 if this was just all one whole, but it's not just one big rectangle, it's 2 separate wholes, okay? So it's 15 over 8 because 8 is the denominator or the total number of pieces in one whole. And having this fraction where the numerator is bigger or greater than the denominator shows me that this is a fraction that has more than one whole, and it's a fraction greater than a whole. This one is filled, and then we have this one over here that has some more in it. So it's a fraction greater than a whole. The other way that you can think about this is that there's 15 pieces that are shaded. So that's my numerator, and then my denominator I'm going to get from right here. Okay, so I wanted just to show you first, counting all the way around and counting by 1/8 so you could really see what we're doing, but it would definitely be faster to say, okay, there's 15 pieces and there's 8 pieces in each whole, right? So we'll kind of try that strategy for C. All right, so C, the unit fraction for one piece. Well, we're just going to look at one whole, right? So if I look at one whole, there's 1, 2, 3, 4, 5, 6. 6 pieces in one whole. A unit fraction means we're looking at one piece out of the whole, so it would be 1 over 6 because there's 6 pieces in the whole. All right, the next one says the total number of units shaded. Well, I know that there's 1, 2, 3, 4, 5, 6, and I can count individually here, but I know that 6 plus 6 is 12 because this whole thing is shaded in as well. So I'm at 12, 13, 14. So there's 14 pieces shaded. Okay. And now we want the fraction shaded. So we said that there's 14 pieces shaded. That's my numerator. And then my denominator is the total number of pieces in one whole. Okay. In each whole, how many total pieces are there? 6. So we take that denominator from there. So this would be 14 over 6. Let me think. Okay, let's try another one, see if it's getting, I'm hoping that it'll be getting easier and easier for us, okay? So for D, the unit fraction of one piece. So if I look, I'm just going to look at one whole, right? So I've got 1, 2, 3, 4, 5. So there's 5 pieces in the whole. A unit fraction means it's going to have 1 on top, and 5 would go on the bottom because there's 5 total pieces, okay? My next column is the total number of units shaded. So I'm going to count. I already know that there's 5 pieces here. So 5, 6, 7, 8. There's 8 pieces shaded. So my fraction shaded 8 is going to be my numerator, right? Because there's 8 pieces that are shaded. And what's my denominator? 5, right? Because if I look at each whole, there's 5 pieces in each whole. And again, since my numerator is bigger than my denominator, 8/5, this is telling me that it's a fraction greater than a whole, which it certainly is because this whole shape is shaded here, plus some on this one as well. So I would expect to see my numerator, my number on top, bigger than my denominator, the number down on the bottom, because it is a fraction greater than a whole. Here's a whole with some more that is shaded as well. All right, why don't you pause if you haven't tried any yet and try to do E and F on your own. If you're not quite sure, pause, do E, check, and then you can pause again and do F and then check. Okay, definitely want a little bit of independent work here though. All right, let's see how we did. So if I'm looking at E, so my unit fraction, which again, unit means one piece. So if it's ever talking about a unit fraction, I would expect to see a 1 on top because it's talking about one piece, okay? What did you put for your denominator here? Again, I'm looking at one whole, not all 3 of them. So if I look at one whole, there's 1, 2, 3, 4 pieces in that whole. So did you put 1/4 for your unit fraction? Good. If you put 1 out of 12, you made the mistake of counting the total in all 3 of them. But remember, so when we're dealing with something like this, our denominator would be the total amount of pieces in one whole, okay? The total number of units shaded. So there's 4 here and 4 here. So 4 plus 4 is 8, plus 1 more is 9. So there's 9 pieces shaded, okay? And then did you put, so there's 9 pieces shaded, 9 over 12? No, say no, Mrs. Gruelle, I'm trying to trick you. So 12 would not be on the bottom, right? Because 12 is the total pieces in all 3 of the holes, but we're not talking about the total number of pieces in all 3. We're only talking about the total number of pieces in one hole. So it would be 9 over 4. Did you get that correct? Good. And if you got tricked up, know that you are in good company because that is the biggest mistake that kiddos make is that they put the total number in all 3 pieces on the bottom. But just remember that we're focusing on one of the holes. If my answer was 9/12, that doesn't represent a fraction that's greater than a whole. And we have actually 2 holes plus some more left over. So if my fraction is 9/4, that's showing me that this is a fraction that's greater than a whole. Okay, there's going to be more than one whole shaded in, which there definitely is. All right, so if you didn't do F yet, I want you to pause and try that one on your own. And then if you're all set, let's check it now, okay? All right, so for F, my unit fraction is, again, unit. I have one piece out of the total. So I'm just looking at one whole, and there's 1, 2, 3 pieces in the whole, so 1/3. Did you put 1/3 there? Good. Okay, and the next one is your total number of pieces shaded. So I have 3 here, 4, 5, 6, 7. Did you put 7 there? Good. And what did you put here for your fraction shaded? So there's 7 total pieces over 3 because there's 3 pieces in one whole. Okay. If you put 9, Again, remember that we're not talking about all three holes together. We're just talking about the total amount in one hole. 1, 2, 3. Okay. When you're ready, you can go ahead and flip it over. And if you're still working on this side or making any corrections, you can pause it and join me on the other side when you're ready. Alrighty. Number 2 says to estimate, to draw and shade units on the fraction strips and then solve. So for this sample they have is 5/3 and it says equals, and then we just write that fraction numbers, which they did that one for us, 5/3. So this thirds and the denominator of 3 tells me that I need 3 pieces in each hole. So the denominator, remember, I'm getting choked up on my words here. Remember, the denominator tells us how many pieces are in the hole. So there's 3 pieces in the hole. So this is split into thirds, and this is split into thirds. Then they labeled them 1/3, 1/3, 1/3, 1/3, 1/3, 1/3 somewhere. And the numerator tells me how many I'm going to shade in. So there's 5 pieces shaded. So 1/3, 2/3, 3/3, 4/3, 5/3. So again, the numerator is bigger than the denominator. So that's telling me that this is a fraction that's greater than 1 whole, which it is, right? Because here's a whole shaded in plus 2 more thirds of this one shaded in. Okay, so let's take a look at A. It says 8/6. So we're going to write 8/6 in numerical form. So 8/6, the 8 would go on top as my numerator, and the 6 goes on the bottom as my denominator. Again, it's telling me that there's 6, and this 6 on the bottom tells me that each hole is going to have how many pieces? 6, right? So do you remember the trick to make 6 nice and even, equal? We're going to split it into thirds first. And once we have really good thirds, we can cut our thirds in half. And that gives us 6. That should be pretty equal in size. So 1, 2, 3, 4, 5, 6. I want to do the same thing to this hole over here. I'm going to make it into 6 as well. So cut it into thirds first. And then cut those thirds in half. 1, 2, 3, 4, 5, 6. And then above they labeled them as thirds, so we'll label these ones as 6. That's our unit fraction, right? What each piece would be called. And how many are we going to shade in? 8/6, and our numerator is 8. So we're going to shade in 8 pieces. 1, 2, 3, 4, 5, 6. And I'm going to do some more of the second one. 7, 8. Okay, so 8/6. I know that this is a fraction greater than a whole because my numerator, the number on top, is bigger than the number on the bottom. So I'm shading this whole in right here because that would be 6, 7, 8. So that would be 8/6. Okay. All right, 7/4. So write that as a fraction. It would be 7/4. Okay. And the denominator tells me how many pieces in the whole. So there is 4 for my denominator. So I'm going to do 4 pieces here. So remember, for fourths, we cut it in half. And then we cut the halves in half. Same thing here. Cut it in half. Cut the halves in half. And then each piece is 1/4. You need to pause at any time. You know the drill. Go ahead and pause. And then how many are you going to shade in? And if you want to grab like a crayon or anything that kind of makes it a little smoother shading, you can do that. I think maybe for next lesson, if I'm going to be shading it, I'm going to bring a crayon with me just to kind of make it smoother and easier to shade. But for this one, I'm going to shade in 7, right? Because it's 7/4. My numerator is telling me that I'm going to shade in 7. So 1, 2, 3, 4. Do I keep going? Yep, I need 7. So I'm at 4, 5, 6, 7. So we almost shaded in 2 holes, right? Okay. So 7/4 is definitely a fraction greater than a whole. My numerator is bigger than the denominator. And I shaded this whole hole right here, 4/4, plus 3 more fourths here to give me that 7/4, which is definitely greater than a whole. Okay. Look at C. So I'm missing this part, but it does say 6/5. So to write that, I've got 6/5. Okay. And then this one here, let's just fill this in because I think I'm going to try to let you work on your own. This one is 5 halves. So 5 halves. Okay. You can pause your video and you can try C and D on your own and then check back with me. Okay. All right. So for C with 6/5, again, that denominator tells me how many pieces are in the whole. So each one of these, I'm going to have 5 pieces, so 4 lines. 1, 2, 3, 4. 1, 2, 3, 4, 5. Just to double check. 1, 2, 3, 4. 1, 2, 3, 4, 5. Just to double check. Each piece, the unit fraction, each one is 1/5. Just good practice for us to put that in there, boys and girls. And then how many did you shade? Did you shade in 6? Good. So it would be this whole thing right here. 1, 2, 3, 4, 5. And then one more to give us that 6/5, right? Thumbs up if you're okay with that. Good. All right, if you didn't try D on your own yet, make sure you do that. So you can pause your video and try D if you didn't do it yet. If you did do it, let's go ahead and check. So for 5 halves, my denominator tells me how many pieces to split each whole into. So 5 halves, I'm going to split my whole in half, split my whole in half, split the whole in half. And what fraction would I write in each one of these? What did you write in there? 1/2, right? 1/2, 1/2, 1/2, 1/2, 1/2, 1/2, 1/2, 1/2, 1/2, 1/2. Okay. And then how many do I shade in? 5, right? The numerator tells me how many to shade in. So here's 1, 2, 3, 4, and 5. All righty. What do we think? All right. And I think you have worked really hard. I think we're going to go ahead today and we're going to cross out number 3. That was kind of a lot of work that we did today, I feel like. It wasn't hard, but just kind of we worked hard to partition those holes into different amounts and work hard to make sure that we were getting equal parts and labeling all those parts. Okay. So remember that our lesson objective or I can statement today was I can build and write fractions that are bigger than one whole. And that was our first experience with that today. I hope that you're feeling more confident kind of as we went on because that was something new today. It definitely helps to actually do it, right? So this is one thing, but I think that I know that for me, even though I'm an adult, like it is helpful to actually build the fractions that are greater than a whole, and it's a little bit easier to see it that way and understand. Okay, super work today, boys and girls, and I will see you tomorrow for some more fractions.